going to head and go over lesson 8-1, multiplying and dividing rational expressions. So we're going to head and get started with that.
Alright, so our first example is 3y times y plus 7 over y plus 7 times y squared minus 9. So we're going to look for some common factors. So we're going to go ahead and expand out what we have. So we're going to take our y squared minus 9 and our y plus 7, 3y. We're going to go ahead and put 3y over with y squared minus 9. And notice that in our second pairing, we have both the top and bottom is y plus 7. When we do that, remember when we have a fraction that has the same numerator and denominator, we go ahead and cancel each other out and reduce to 1. So now we have 3y over y squared minus 9, and that is all we can go ahead and do. So that is our answer, 3y over y squared minus 9. Another thing we'll be looking at is when would this function be undefined, or expression in this case. So we always try to recall that when we look at fractions, we always remind ourselves we can't divide by 0. So that is the same thing here because all we have is a fancy fractions. That's all we have. So we're going to take our denominator and we're going to set it equal to 0 or solve for each form of it. So y squared minus 9 is a difference of 2 squares, so that factors out to y minus 3 and y plus 3. We're going to go ahead and keep the y plus 7. We're going to set each factor to 0 to go ahead and figure out for what values of y we can't have. And when we do that, we find we can't have -7, 3, or -3, because if we plug in any of those values, we'd end up with 0 in our denominator.
Go ahead and take your time to go ahead and try those. When you work this one out, you should get C.
So we're going to take a look here at what value of p makes our function or expression undefined. So we're going to take a look here. We're going to read our item, and we want to find out what value of p would make our denominator equal to 0. So to solve that, we're going to look at some possible answers. This was a multiple choice question, so we can eliminate a and b and factor the denominator, and there's a couple things to do. So when we go ahead and factor, we get p minus 5 and p plus 3. When we set both of those equal to 0, we get 5 and -3. So in the example that we had, our answer would be B. Do pay special attention to this example problem that you guys will need to do on your own. This is a quiz question.
Go ahead and ignore that. That's not going to be a quiz question.
Right, example 3, we have a to the 4th b minus 2a to the 4th, all over 2a cubed minus a cubed b. So what we're going to first do is factor the numerator and the denominator. So we're going to factor out the GCF, which in the numerator is a to the 4th, and the numerator, in the numerator a to the 4th, and the denominator a to the 3rd. So we're going to go ahead and do that. Since we have the a's on the outside, we can go ahead and cancel those out, and we'd be left with a to the 1st power by using quotient property for properties of exponents. We're going to factor out a -1 on our b minus 2 set that they match top and bottom. And we're left with that. We're left with -a over 1, or just -a. Do pay close attention.
Go ahead and try this one on and simplify to what you can get. Pause the video as needed.
Into this example problem.
You will notice that we get
So here we have multiplying rational expressions. a couple rules just to go ahead and help us out. When we multiply, it's the same as when we multiply fractions. We multiply across, top and bottom. When we divide, we're going to go ahead and keep our first fraction, flip the second, and then go ahead and multiply across. But the rules for multiplying and dividing rational expressions is the same as multiplying and dividing fractions. So here we have 8x over 21y cubed times 7y squared times over 16x cubed. So you could go ahead and expand this out and make sure that you cancel everything out, or you can use your properties of exponents, whichever one you prefer. In this example, they're going to go ahead and use the expansion, which, as you can see, it's not ideal just because of how much space it would take up. But when we do that, everything cancels out up in the top, so that leaves us with 1, and in the bottom we're left with 3 times y times 2 times x, which would just be 6x squared y. So our answer would be 1 over 6x squared y. So here we have division using rational expressions with one term, the monomials. We have 10mk squared over 3c squared d divided by 5m to the 5th over 6c squared d squared. So we're going to multiply by the reciprocal of the divisor, which just means we keep the first fraction and we flip the second fraction and go ahead and multiply. Again, we're going to go ahead and expand out here so you can see exactly how they're canceling everything out. When you do that, you see that we're left with 2 times k times 2 times d in the numerator and 1 times m 4 times in our denominator. So when we go ahead and simplify that on the with simplifying, we get 4k squared d over m to the 4th for our final answer.
Okay. Go ahead and try this problem. When you do, you should get D.
Okay, example 5. We have k minus 3 over k plus 1 times 1 minus k squared over k squared minus 4k plus 3. These are a little different because these are polynomials. They're not monomials. So what we have to cancel out is what's inside the parentheses has to be the same top and bottom. So here we have k minus 3 times over k plus 1. We're going to leave that alone. On the second fraction, though, we are going to go ahead and rewrite that. 1 minus k squared is a difference of 2 squares, so that factors to 1 minus k times 1 plus k. And k squared minus 4k plus 3 is the same thing as k minus 3 times k minus 1. So when we write these out, we're just going to cancel out what they have the same top and bottom. And if you notice, the only thing that's different is that we are left with a negative 1 in the numerator. So our answer is going to be negative 1. It is okay to get an answer of negative 1 or even just 1 for examples like this. That is actually very possible to go ahead and do. Our second example using division is 2d plus 6 over d squared plus d minus 2 divided by d plus 3 over d squared plus 3d plus 2. So again, we're going to follow the same rules for dividing with fractions. We're going to keep the first, flip the second, and go ahead and multiply. So we're actually going to go ahead and have 2d plus 6 over d squared plus d minus 2 multiplied by d squared plus 3d plus 2 all over d plus 3. So we're going to go ahead and factor and cancel out what we have, the like factors, the numerator and the denominator. So we're going to factor out a 2 from 2d plus 6 to get 2 times d plus 3. And we're going to factor d squared plus 3d plus 2 by getting d plus 2 times d plus 1. And we're going to factor d squared plus d minus 2 to d plus 2 times d minus 1. We can only cancel them out if they actually are true pairs. So when we do that, we're going to be left with 2 times d plus 1 in the numerator and d minus 1. So by going ahead and simplifying, there's nothing else we can go ahead and do with this fraction. This is the simplest form, which is 2 times d plus 1 over d minus 1. You could alternatively also see this as 2d plus 2 over d minus 1 if they wanted to go ahead and distribute that 2 out. Do pay close attention to this example problem because this is a quiz question.
You can ignore that statement. Go ahead and try this one. And when you do, you should get A.
All right, example 6. We're going to go ahead and have complex fractions. A complex fraction is just where we have a fraction in the numerator or the denominator within a fraction. So in this case, we have 3 fractions. We have our fractions that's in the numerator, and we have our fraction that's in the denominator. This is just a fancy way to show that we're dividing. So we've already done an example like this. So if we just go ahead and rewrite it out linearly, instead of having it vertical, we're going to have it horizontal. So this is saying the same thing as x squared over 9x squared minus 4y squared divided by x cubed divided over 2y minus 3x. And we're going to still follow the same properties for when we multiply fractions or divide fractions. Keep the first, flip the second, and multiply. So we end up with x squared over 9x squared minus 4y squared times 2y minus 3x all over x cubed. Our next step is to go ahead and factor. When we factor, we're left with x times 2y minus 3x. And in the denominator, we have 3x minus 2y times 3x plus 2y times x times x times x. So there you go ahead and expand everything out so that you can see what they cancel. And we find that we're left with 1 over x times 3x plus 2y, or negative. So our final answer is negative 1 over x times 3x plus 2y. Do pay attention to this example problem because it is a quiz question.
Do ignore that. For the comments
And that is the end of today's lesson.
For the comments about that, do ignore. I did a previous recording. This is actually the recording from last year. And we'll go ahead and take care of that. That is the end of the lesson, and I will see you guys next time.